4.5, graphs of sine and cosine functions. What we should learn, how to graph translations, moving it up, down, left, right, and then how to do real life problems. It's about translations. It's like in all our parent functions, anything on the inside moves it left and right. It's a shift, left or right. But in trig, we call that a phase shift. And all we're going to do is do like we always do. Now we'll have a new start point, which is the phase shift, which is wherever the graph is. That's our phase shift. That's where we're going to start. And then you have to figure out where you end. Well, the ending point is just, you have the period, wherever the period is. You go plus the period, which is normally 2 pi over b. Now get to your endpoint. So that's the idea. If you start with our phase shift, that lets us know where we should start at. And then you just add the period, because that's going to be 1 rotation. Now get your new endpoint. Let's do an example right here. So in this graph, we're going to find all the basics. We're going to find the amp, the period, and in this case, we have a phase shift. For amp, the number front, 1/2. As high we can go, 1/2. I'm just going to put that in. I'm going to put this little dotted line that's only for us. It's not part of the graph. We know how high we could go and how low we could go. Again, it's not part of the graph. That's just for us. Our period. Now, our b is the number in front of the x. So in this case, we don't have one. It could be here or it could be here. Like, it depends on where they put it. So in this case, we don't have one. Our period is going to be 2 pi over 1. Our b is 1 still. So just 2 pi. So take out like 2 pi to finish our rotation. Our phase shift is this guy. Remember, inside opposites, we're going to move it right pi over 3. We're going to start at pi over 3. And much like before, let me do this in red. This is just for us, so we know where we start. We start at pi over 3. This is our starting point. Let's start pi over 3. If we want to know where our graph ends, we're going to have to add the period. Plus the period, which in this case is 2 pi. Now gives our endpoint. The end of one period of the graph. Common denominator over 1. Let's look at 3 times 3. I get 6 pi here. 6 pi plus pi is 7 pi over 3. So we're going to end at 7 pi over 3 right here. We do that again. Again, these little dots are just for us. We know what our graph looks like. So this box here is where our graph, our main part of the graph is going to be, the one we're going to draw. It's a sine graph, so it starts at origin. We're going to go up and go down in this little box here. Remember, the graph goes on forever. We have to fill up this whole grid. We're going to go backwards. Same idea. Okay, let's get started. It is a sine graph. We're going to start at the origin. We're shifting it to pi over 3, so we're going to start right here. We're going to end at the origin, right there, that point right there. Halfway. Now you could figure out halfway, as we always do. Add them up and divide by 2, but most of the time you can just eyeball it. 4 pi over 3 works. Right, that's about halfway. If you're not sure, you can always find halfway by adding them up. Pi over 3 plus 7 pi over 3 is 8 pi over 3. Divide that by 2, times by 1/2, and you get 4 pi over 3. That always works, but most times you just eyeball it. Halfway between these two is my lowest point, or my highest point, sorry, which would be like right here. There we go. Halfway between these two is my lowest point of the amplitude, right there. And then connect that graph. And again, it goes on forever. And we're going to see it backwards. Now, it's a sketch. I'm not going to go too crazy about this. But like from here to here, negative 4 pi will probably be around there. Because it's just a sketch. I'm not going to go crazy about it. So like that. That's how I do horizontal translation. Inside opposite, it moves it right or left. And then wherever it moves, that's your starting point. Add the period to it, whatever the period happens to be. And I'll get you your endpoint. Let's do another one. A couple things are going on here. We have an amp. Amp is not negative 3. Amp is always positive. Amp is just a distance. It's 3. The negative does have an effect. That would be vertical flip. Vertical flip. Doesn't open upside down. This is a cosine graph. Cosine graph normally looks like this. But if it's a negative cosine graph, we're going to flip it. It's going to be upside down like that. Normal cosine graph looks like this. With the negative, we're going to flip it upside down. That does have an effect, but it does not affect the amplitude. Amplitude's still going up 3, down 3. Actually, let's do that. Amplitude's still this. That's still our amplitude. Okay. Our period is 2 pi over b. Now, what's our b in this case? Our b is 2 pi. But we should factor it out first, because it's going to affect our shift. You always have to factor it out if it's not already factored out for you. This is going to be negative 3 cosine. Pull out the 2 pi. When you pull out the 2 pi, that's the number in front of the x. You just left with the x here. 4 pi divided by 2 pi is just going to be 2, like that. So that's the proper way of having this equation factor out that 2 pi. It looks like this. So our period is 2 pi over 2 pi, which is 1. And now we have a phase shift. Inside opposite, it's going to be negative 2. So we're going to move it the whole graph left 2. So our graph's going to start right here at negative 2. Now this is an easy one. We're starting at negative 2. And we add the period, which is 1. Period right there. We're going to get our endpoint of negative 1. I can do the math on that one. So we're going to end right here. In that little box right here, this little rectangle, that's going to be our whole graph of cosine. Because we're starting at negative 2 because of our phase shift. Our period's 1, so the whole graph ends 1 over. And our amplitude is 3 to negative 3. Now, keep in mind, it is a negative in front. It's going to be an upside down graph like I talked about. It's also a cosine graph. Remember, cosine graph starts at the amplitude. Normally we start right here. But we're going to start down here because it's negative. We always start at in the same spot right there. Halfway between is our lowest, all the way up here, halfway. We'll estimate. Remember the way cosine works? Halfway between these two is where we cross. Halfway between there like this and like this. And this graph-ish, not my best graph, is our graph of this guy. And again, it goes on forever. If you want to figure out, you can keep on going. It's just an easy period. You go add one over, and this is where our graph's going to end right there. The same idea. Halfway, halfway. I should fill up this grid right there. And remember, these lines are only for us. They're not part of the graph. And I say that because eventually we're going to do cosecant and secant graphs, and they have lines. And tangent too. For us, these are just lines to help us graph it. That's all they're for. They're not part of the graph. Again, I say that because tan, cotan, all the rest of them actually do have asymptotes and stuff that you have to worry about, but not for sine, cosine. This is just the graph. Okay, let's talk about vertical translation. Vertical translation is, for me, the easiest one. This is our new middle. The new middle. If you notice when we do these graphs, there's always like the middle line. It's always in the x-axis. That's because it's always +0. There was no vertical shift before. Now there is. So that's just our new middle, also known as a printable axis. I always just call it the new middle though. So our new middle is going to be 2, and I'm just going to mark it on the graph. Here's our new middle. And for me, this is going to be easier than the horizontal translation because we're going to do everything the same. What's our amp? Well, our amp is the number in front of the cosine, 3. That means, like it always means, you go up 3 and down 3 from your new middle. It used to be from 0, but now we're moving everything up 2. This is my new middle. And we're going to go up 3, up to 5. We're going to go down 3, down to -1. So this is the highest part of my amp, is 5, and the lowest part of my amp, -1. I'm going to go up 3 and down 3. On my period, 2 pi over b. We actually have a b in this case. B is 2 pi over 2, just pi. If we have no phase shift, we're going to start at 0, and we're going to go over to 2 pi to here. We're starting at 0. You don't need to do these things. I do it to help us see. By the way, if we're going backwards, we'll go back 2 pi. So we'll set an n right here also. Like in this box is our primary graph. And that's pretty much it. Now we just got a graph. What are we doing? Cosine graph? Cosine. You always want to remember what the basic graph looks. Cosine starts at the amp, ends on the amp. Halfway is lowest. Halfway between these two is where I cross. And that's our cosine graph. We want to replicate that right here. So we're going to start at the amp. We're going to end at the amp. Halfway, we can eyeball it, is pi. We don't need to eyeball it. It's right there. Pi. Halfway between those two is pi over 2. That's where we cross our new middle. And sitting over here. There we go. Should be more of a U. I'm going to do sending backwards. I'm going to fill up this graph. Probably a little something like that. There's how you graph cosine. That's how you do a vertical translation. For me, that's the easiest one. It just changes your middle, and then from there, you just base everything off of it. How about if we go backwards? On this graph, they want us to find the amplitude, the period, and the phase shift of the sine function. So this is a sine function. Basically, we're trying to do this. We have a, it's a sine function, sine b x minus c. And we want to figure out what a is, what b is, and what c is. A, amplitude is probably the easiest one. It looks like, to me, those are the marks. It's kind of hard to see. Oh, I'd say it goes up to -2. Goes to 2 and down to -2. Their amp is 2 because it goes up to 2 and down to 2. But if you look at the graph, it's upside down. A normal sine function looks like this. This is going upside down. I'm going to put a -2 up here for our A. Our amplitude is still 2, but there's like a vertical. That's A. How about B? B has to do with the period. The period equals 2 pi over B. And that's the equation we got to solve. We're trying to find out what B is. Well, all we got to do is figure out what the period is. Now, this graph makes it a little tougher because we're going from -pi over 2 to 3 pi over 2. The way you find the period is where you end minus where you started. 3 pi over 2 minus -pi over 2. Two negatives make a positive. We get 3 pi over 2 plus pi over 2. I just get 4 pi over 2, also known as 2 pi. My period's 2 pi. Now all you gotta do here is solve the problem. This one's easy enough. You can just look at it and go, wait, those are equal graphs. B equals 1. Done. If you didn't, you can always cross multiply and get 2 pi b equals 2 pi, and then divide by 2 pi, and you get b equals 1. That's how you normally would solve it. In this case, b was 1, so it made it really easy. Now, the easiest one of all these is actually c. C should always be the easiest one. You're just looking at for where should the graph start. There's actually lots of ways you can answer this. For us, the graph is starting right here at -pi over 2. That's my c. -pi over 2. That's where my graph starting at -pi over 2. My whole equation will be this. Y equals -2 sine x plus pi over 2, right? When you plug in a negative, double negative makes it a positive. That's why we move left. But honestly, that's only one answer. I just realized I could also done this way. Y equals 2 sine of x. If I did it this way with a positive sine graph, well, what does a positive sine graph start off? Right here. It would be right there, this guy, which I believe is just pi over 2. I could also done it this way, where I do a positive amplitude, and then my starting point would be right here at pi over 2. Two equally good answers, unless they specifically said they wanted a positive amp, which they did not. Either one of these is fine. If we want to start right there, it makes it a negative sine graph. but you shifted left pi over 2. If you start right here in the middle, it's a positive sine graph, but you shifted right pi over 2 to negative pi over 2. Okay, last one, we're gonna do mathematical modeling, which is the same thing we just did, but now with the word problem. So here's the time of we're at a dock and the sea level is going up and down, starting at midnight. They want us to use a trig function model to model the data. Let t be the time with time equals 0, midnight. So this is 0, 2, 4, 6, 8, 10, and 12. First thing we do is plot the data. Here's your thing. 0, 3.4. 2 is 8.7, 12.7. 6 is 9.1. 8 is 3.8. 10 is like almost 0. And then 12 is 1.2, like that. So that's our data. To me, this looks probably best like we could do a cosine graph. We start here. Or we could do like a sine graph that starts in here somewhere. So it kind of depends. So let's do a cosine graph. So if we're doing a cosine graph looks like this. Y equals cosine b x minus c plus d. Like that's our basic cosine graph. We're going to have to find all these things. The amplitude, the period, the phase shift, and the middle. And I always start at the middle. So you want to find out what the middle of this graph is. So you look here, the middle is going to be like the max point minus the midpoint divided by 2. So the middle of anything, you take the max plus the min and divide by 2. So our max here is 11.3 plus the min 0.1. You get 11.4 divided by 2, which is going to be 5.7. That's your middle. Around 5.7 is the middle of our graph. 5.7. Then I do the amp. The amp is just from the middle to the highest point or lowest point. Either way, that's the amp. So to find the amp, we're just going to do the 11.3 minus the middle, 5, which is 5.6. Okay, only 2 more left. B, that's the period. So remember the way we find B is always the same. The period equals 2 pi over b. And then what's the period in this case? Well, it rotates every 12. It goes from midnight to noon. So that's a 12-hour period. This guy's just 12. We gotta solve this. 12 equals 2 pi over b. Cross multiply. That is going to be 2 pi. And that's going to be 12b. Trying to solve for b, divide by 12. And you get b equals 1 over 6, pi over 6. That's our b. Last one. And now all that wouldn't change if it was sine. If we're doing sine, none of this changes. It's all the same, except for c. C is where your graph should start. It's a shift where the graph should start. With cosine graph, that's what we're doing. Start at the top, go down and back up. If we're looking at this graph here, it's like connect the dots. If it was a cosine graph, where should it start? I would say right here. That's what a cosine graph would start at. We're going to say 4 is our c. That's the only thing that changes if we did sine. If we did sine, we should start right here. We have to figure out what point that is. But since we're doing cosine, our graph would start right there. That's the only difference. So there's our equation. Y equals 5.6 cosine of pi over 6 x minus 4 plus 5.7. That's our model for this data here. And then the boat needs at least 10 feet of water to the dock. But we just got to figure out where 10 is. 10 should be right here. And for that, we have to figure out what these points are. We're going to use a calculator to do that. Let's do that real quickly. Here's my calculator. I already typed in the first part. Now, this part, I need pi over 6. Second, pi divided by 6. And then I'll open parentheses, x minus 4. Close the double parentheses, the one I had 2 of them on there, plus 5.7. And then over here, we're going to put 10. Now, a little trick. I already did the window because early on I did it by a lot of the points to figure out what the window was. So that's why my window looks perfect. Because earlier I applied these points. I just that window right there. So you might have to play with the window a little bit. Anyway, I got to find those 2 points. So we're going to go second, calculate, intersect, and then we just want to get close to our intersection point. There's one over here. You just got to get close to it. Hit enter a couple times. First curve, then it jumps to the second curve. Hit enter, and I get let's say 2.7. We'll estimate that. Then we're going to do the same thing for the other point. Second, calculator, intersect. We're going to go over here, and then hit enter a couple of times, and we get 5.3, we'll say. During what times? I'm going to say about from 2 a.m. to 5 a.m. It's about those two. And that's the video.